Okay, Physics 11H. I'm just going to introduce circuits in this video really quick. This is a unit we'd usually do a lot of cool labs for, of course, but we're going to just play with a simulation this week for it. Next week we might do a little bit of modern physics. There's also some simulations for that, and then we'll pretty much just review to make sure everybody's on a good footing for next year for AP Physics C. Hopefully quite a few of you are taking that. I think some of you are, so that's good. But anyway, circuits. So when we say circuits, what we're talking about are batteries, wires, light bulbs, LEDs, all that kind of stuff. And it builds off of our last unit of static electricity. So let me just kind of give you the idea here. Say this is a piece of metal, a conducting piece of metal, right? Well, in that metal, there are a bunch of valence electrons floating around, right? Well, it turns out if you put a bunch of positive, let's say you put a bunch of negative charge over on this side of the wire. Let's say this is some just random piece of metal, right? A bunch of positive charge over on this side of the wire. The electrons, the valence electrons, will move over to this side of the metal, right? They actually move. It become polarized, the wire. This side would become positive. This side would become negative. The electrons would move. That's called current flow. Current is the movement of electrons, right? That's pretty basic, right? You can push electrons around in a conductor with an electric field. Basically what happens here is you get an electric field through the wire like this, right? And that draws electrons upstream. So that's another way to look at it in terms of electric fields. All right, so how do you do this to a wire? How do you make it one side positive, one side negative, and cause current flow? Well, with a battery. You may remember from chemistry this old diagram. I don't remember all the ion chemicals and that sort of thing, and I think you had like a piece of zinc and copper, right? Some sort of solution. And the salt bridge, right? So you could put a meter here. You could actually measure the current flow, and what happens is we get this chemical reaction happening here in these two sides, and we get ions flowing through the salt bridge, pushing electrons onto one of the anode or cathode. I always forget this. And then through the ammeter, right? So the old electrochemical cell. This chemical reaction causes a polarization, right? One of these tends to gain electrons, one of these tends to lose electrons, one becomes positive, one becomes negative. That forces current flow through this wire. That's what the electrochemical cell is doing ultimately. We force electrons through this wire over to the other side, and it's because of the chemical potential difference here. Potential difference, chemical potential difference. This matters. When we get a potential difference, meaning this whole work done idea, when there's an E times a D, an electric field times a distance, that's our potential difference. When we have a potential difference, we can move charge around. If we put electrons in here, just like the parallel plate, if we put electrons in here, they're going to start swimming upstream, just like trout or something. All right, they start swimming upstream. So a battery is essentially an electrochemical cell packaged inside of a nice metal housing, right? And what it is, it's actually a coil of materials kind of wrapped up sometimes, or it's like a paste with a anode or with a cathode anode put down in it. And anyway, battery has a positive side and a negative side. So when we attach a wire across a battery, right? Say this is a wire, I'm making it big. What happens in that wire is an electric field sets up. An electric field sets up. All right, so let's say this line is the electric field. I'm kind of drawing it poorly, but This is the electric field. So the electrons that are in that wire start automatically going counterclockwise around this wire and getting drawn into the battery. What happens is, actually, the whole wire itself gets polarized, believe it or not. The surface of the wire gets polarized. And imagine I looked at a piece of the wire and positive charge was here, right? Negative charge was on this side of the wire, and I'm an electron in the middle. Well, the electron in the middle is going to get repelled from these charges up here, right? They're just going to get pushed away from these ones, and it's going to get drawn towards these ones, so it's going to move that away. All right. So what the battery does is it applies electric forces to the electrons in the wire, causing current flow. That's pretty cool. So batteries have a voltage, right? Actually, a single cell. So if this is like an A, let's say this is a C cell, right? A C cell. Its voltage is 1.5 volts. An A cell is a little bit smaller. Its voltage, or double A I should say, its voltage is also 1.5 volts. A triple A, even smaller, believe it or not, right? Its voltage is also 1.5 volts. They all have the same voltage. So what makes them different? Well, the C has more chemical in it, so it lasts longer. All right, that's the whole point of a C battery, D battery. It has the same, I shouldn't call these batteries. Technically, a battery is a collection of cells. For instance, a 9-volt battery. Do I have one here cut up? I thought I used to have one up down in my lab here, down in my basement here. But anyways, a 9-volt battery, this is kind of cool. If you were to cut open a 9-volt battery, and we were at school, I could show you this, right? If you were to cut one open, what you find are 6 little tiny quad A batteries. They're even smaller than triple A's. They're kind of stacked up. If I looked at it from the top, it would look like this. And they're stacked up in series with each other. 1.5 times 6 is 9 volts. All right. So that's kind of interesting. When you put batteries in a device, like let's say you have like something that you unscrew it, right? And then you go inside and it's like, oh, look, it takes 3 AA batteries. The one goes this way, this one goes this way, and then this one goes this way. Well, they're connected up like this, right? They're connected here, 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 and then these are the ends that go into the device. 1.5, 1.5, and 1.5. So 1.5 plus 1.5 is 3. 1.5 plus 1.5 is 4.5, and so on. All right. So when you put batteries in a device, they're in series with each other. You add up their energies, and if they're in series, you add up their energies. We're going to talk about parallel and series later on. So the whole point of this first activity is just to look at a simulation, Ohm's law, and I'm not going to make a video of the actual simulation here. It's very easy. What it is it shows the equation V equals IR, and this is called Ohm's law. All right, voltage, current, and resistance. We haven't talked about this a whole lot yet, resistance. In the circuit simulation lab, we're going to see how we derive resistance by controlling voltage, measuring current, and making a graph. It turns out it probably makes more sense to write this as V equals RI. If you plot voltage versus current, the slope of the line ends up being resistance. So the first lab here, you're just going to mess with playing with these variables. And it's a simulation. You're going to mess with the number of batteries, the voltage. You're going to see the current, resistance. You're just going to play with the simulation for a minute just to see how they kind of all relate. All right. The circuit lab here is really comprehensive. You don't need to know what volts and amps means initially, okay? You're going to answer the questions, and then there's explanations throughout it about stuff. And let me just quick talk about current really quick. So voltage, or potential difference, the unit for it is a V, which is a joule per coulomb of charge. Current is the amount of charge flowing through the wire per second, coulombs per second. An amp, or sorry, I just messed that up. It's called an ampere, an amp, or an A, which is a coulomb per second. And the unit for resistance is a volt per amp. All right, which is well, it's a joule per coulomb per second. So it's kind of a strange thing it comes out to be. We call it an ohm. And the symbol for that is a capital omega, which is kind of fun. All right, so resistance we'll learn about in the next lab, what it is exactly. It's just basically different materials don't conduct so good, so well. So you can apply a voltage, and the higher the resistance, the less current that flows through it because it's resistive to the flow of current. It's just a really basic crash course, kind of all over the place a little bit, but just trying to get a little bit of stuff to you to get you going. I think you'll find the circuit simulation lab really does teach you everything you need to know about circuits for our purposes. And we're not going to have any quizzes on circuits. We're just going to do this activity this week and then move along. There are some homework problems right in this, but I'm going to basically give you this and let you roll with it for the rest of the week. All right, have a good one, guys. Well, I'm going to make a separate update, just kind of a general stuff and all that sort of things. All right, I'll talk to you later. Bye.